Okay. So yeah, so let's talk about Takshila. So it's like we are expert in training people who are just starting to join industry in VLSI and have no background regarding this. Apart from that, anyone who is working in some different domain, let's say layout designers, and they want to switch their career into circuit design, they are most welcome. Regarding course details, we have multiple faculties and they have more than 10 years and 15 years of experience in industry, and we have access to standard EDA tools like Cadence and Synopsys, and that will be accessible to you all from 24/7, you can say. And we have collaboration with multiple companies, like as you can say that touching 200 plus companies, mostly so service based as well as product based. And after this course, we help people with the preparation of interviews also, and then we try the last point everyone gets placed. That's what I can say. Yeah. So well, why to select Takshila VLSI? Well, as you can say that we have 100% of placement assistance, and then our course and curriculum is well aligned with industry. The courses have been designed in such a way that everything latest is already covered. Apart from that, some extra is given by trainers so that students are much more prepared for upcoming challenges. Then we can say that we have 24/7 lab support during the entire training course. We'll be taking theory as well as the practical sessions. Whatever circuits will be taught, and they will be, there'll be a demo on Cadence also. And apart from that, that learning of Cadence tool, we teach also to create test benches and everything else, and intricacies of circuit design, which you'll not find anywhere in books also. That's what I can say. And the rest you can see yourself, like it's a low cost value for money. And then yeah, let me take you to the video of Takshila Vidasai. Okay, just a moment. I think please confirm once you are able to see the video. Okay, just a moment. Okay, yeah. Please tell me if you can see the video. Oh, I think audio is not visible. Okay. Can you hear the audio? Yes, can you confirm if you can see the audio also apart from the video?
साथ में खाएगा तुम लोग
Okay, so that was all about the video. Let me teach in more detail. Okay, so yeah, so that was about the video. Let's say have some more snaps from the video itself. This is all the infra we provide for VLSI learning. These are all our labs, peoples, faculties, and the setup which we provide for learning. Okay, these are some more photos you can see. Okay, so as I said that we have offices in like Hyderabad as well as both Bangalore, and also we provide online sessions, whichever seems comfortable to you. Yeah. So this PPT have course information also about this analog circuit design, and it's this course is mostly online course which will be held on weekends so that people who are working they can also attend. And the course duration will be for 16 weeks. Uh, okay, so although 16 weeks is quite kind of less for analog circuit design, but yeah, we try to cover as much as we can do with more accurate and more relevant information. All I can say that people who are enrolled in the course, they are supposed to do their homework, on regular basis to be well aligned with, a curriculum. Okay, the tool we'll use for this course will be Cadence Virtuoso. It's our industry standard tool. Okay, not only with the we have in that Cadence we'll be having our Virtuoso schematic editor as well as ADL. Okay, so mostly like all kind of simulations which are normally done in industry will be taking care of that, AC simulations, DC simulations, even transient noise and transient simulations, stability analysis, everything will be taken care of. Okay, I think someone's mic is on, so maybe I'm not sure, some noise is coming. So yeah, thanks. Yeah. Okay, so that was about the course. So yeah, all course materials will be sent to you to your home. That's what I can say. And then eligibility for this course, anyone who is doing M.Tech, ME or MS in VLSI or embedded system, they are they must do it. Not only M.Tech, but I'll say people who are doing B.Tech also, and if they have good fundamentals of subjects like signal and systems, control systems, network analysis, they are encouraged to join because we have been teaching people from basics. Okay, if they are going to align on day-to-day basis, I'm sure that they'll be able to learn all required things. Okay, because whatever is present inside most textbooks as well as what is required in industry, we take a mix of that, and each detail, each topic we spend wherever we think that attention is required, we spend more time, and other topics which are just related to it, we just move swiftly on that thing. So maybe I'm sure that, let's say you have learned small signal analysis. Okay, so if I'm teaching you small signal analysis, I'm sure that I'll spend more time for you to understand it, but once it is done, we'll simply keep on assuming and moving ahead, so that you'll be obviously you'll be aware of all formulas on all tricks, and maybe in upcoming sessions, let's say big circuits, if I'm writing some equations, I'll make sure that you know it, and that's how we plan to move. Okay, then people who are working in VLSI domain as layout designers, because they have to deal with circuit designers from day-to-day basis, and this course is actually way more useful to those people because they already have access to layout, and now they know circuit design. So it will be best way for them to like uh, get growth in industry, or maybe rise on corporate ladder. That's what I can say, because mostly what happens that circuit designers don't know much about layout, and layout designers don't know about circuit. So once who's having command of both of these things, it's great. Yeah, you must have felt it for sure. Anyone who is working as a layout designer, they must be knowing this for sure. Okay. Then we talk about industry salary scope. So starting packages like as for circuit designers are 4 to 6 lakhs. So that's mostly for service-based companies. But and they say that for product-based companies, it's 15 to 20 lakh. Okay, and mostly it's assumed that people who have more than 3 years of experience, they can easily switch into product-based companies. But I can assure you that if you are paying proper attention, maybe you can join product-based companies now also. All you have to do is put some hard work. Then if you talk about industry growth, yeah, people who are team lead, like maybe 6 years or 7 years of experience, they are getting 25 to 30 lakh, and people who are managers, yeah, obviously 60 to 80. But one more thing I'd like to add that this is a kind of general salary, which is, like the average of all companies. But yeah, there are companies which pay way more than that, and that's for sure. Like the team lead salary is more than 40 lakh also, and product based companies for freshers are like they are giving 25 also, and managers. Well, I don't know much, but I'm sure that it is may way more higher than this. Okay, so that's about the salary scope in industry. Let me move to next slide. Well, regarding placement support, so we have tie-ups with more than 200 hiring companies, and you'll be come to know about list of companies. We have contacts everywhere, and after this course, we'll make sure that all of you are placed. Complete assistance will be provided, but again, it's on you also. You have to do hard work, really. Yeah, like we take mock interviews also, and these are the list of companies. As I say that we have Capgemini, HCL, Wipro, Cyient, AMD, Synapse. Okay, so you can see it's a mix of product as well as service-based companies. So again, it's totally on you whether you're able to crack it or not. But we'll make sure that we teach you everything so that you should be able to crack the interviews. Okay. This is Gateway for Semiconductor Industry. So these are the list of companies you can say. This is a list of companies, and there are many more which we have not been able to add in this picture. So yeah, you can see that there are product based as well as service based companies, and people are placed actually in these companies from here. Okay. So this is the list of 2024 batch placed students. Yeah, we can see the names. People in layout design as well as physical design and circuit design also, they have been placed in different companies. Okay, maybe, yeah. Then further, we have more list ahead. Yeah, here we go again. Yeah, you can see. Well, the list is never ending actually. Yeah, you can the people in Digicom, Micron, and Semi, Savitech also. Actually, Savitech they were nice, very nice. That's what I know. Okay, so now let's talk about the curriculum. It's all about till now we have talked about the course and everything and about Takshila, but yeah, let's talk about what we actually teach. Okay, so the modules are the course have been divided into several modules, and each module strategically cover each topics, and second topic will be dependent on first itself. So if you want to if you think that you can directly jump onto the second module or third module, you should make sure that you know first module clearly because everything is dependent on first thing. As I say that on initial modules, I spend more time on basics, but in upcoming modules, the more time is spent on circuit architectures or system architectures because we simply assume that you are well aware of basic things, which will be taking care first or second modules. Okay, so if we talk about modules, first we will cover device physics in this course, where we will teaching you semiconductor basics. Yeah, we'll spend some time on it. Then we'll be teaching you like a MOSFET, its structure, its operation. And when we talk about MOSFET structure, it will not be just like a PPT thing uh, where you can read some stuff and move ahead the way it's written in textbooks or shared by people on LinkedIn mostly. But it will be quite like aggressive and will be taking care of each and every parameter about MOSFET based on industry level itself because this topic is related to layout also. So we'll be covering type of devices, type of node, like different nodes, the things associated with MOS, like its capacitance and everything, type of capacitors, type of different devices. We'll be taking care of all these things. Then when MOS basics are done, we'll be moving to basic circuit design with MOS itself. So we'll be covering MOS operations, its behavior, its regions. Okay, then its small signal model. Okay, and many more things. And again, things will be all practical things will be shared while teaching you basics. That's what I can say. Then short channel effects for sure. Well, after this basic module, we'll be covering Linux because, in order to work in VLSI, you must be well aware of Linux because all tools are mostly based on Linux only. Okay, reason we are the people who are responsible for building computers. Okay, so we are designing computers when the computers were not exactly there. So the first operating system was Linux itself. So all softwares were built on Linux only. So till today also, their base is Linux only. Plus, Linux is flexible and you can customize it for different users. Okay, so the UI you say normally, let's say that you are going to use Facebook. So Facebook has a particular user interface. But what happens in Linux that okay, for a particular tool, let's say that you want it for your company, so we can customize it for you also. Okay, its UI will be different. Plus many more things. It's secure also. It's fast also. You know, and well, secure means like it can be stored in data centers and many more things are there. I'm not an expert in Linux, but yeah, it's way better than Windows. That's what I can say. Yeah, so we'll be teaching you basic Linux commands so that you are able to access directory structure. You will be able to know directory structure. You'll be able to copy and paste and move required files which are needed in your simulations. Then how to launch tool. I mean whatever Linux is required for you to work on Cadence, we'll make sure that you know it. Then we'll be moving to single stage amplifiers. Again, they are way more important because they are fundamentals. Okay, so we'll be covering different type of amplifiers like common source, common gate, and source follower. And we'll be covering application of each particular amplifier. Like we are not just teaching you that okay, this is called common source and this is called common gate. Like why common gate is needed and in which application is well suited. Okay, so we'll be talking about practical scenario also. Then we'll be talking about Cascode stages. Yeah, Cascode has its own features and it is well used in the industry. So yeah, we'll be covering that also. Then after single stage is done, we'll be making sure that we are teaching you small signal modeling also in single stage amplifiers. Then we'll be moving to differential amplifiers, where we'll be taking care of differential signaling and signals, single-ended signaling, and their pros and cons. And obviously, differential has its own benefits. Single has its own benefits. We'll be taking care of that. I'm not saying that one is obsolete and one is old. Okay, everyone has its use in today's time based on the application. So nothing is obsolete in analog design. That's what I can say. Plus, right now nowadays people are more worried that okay, AI will take your job. I'm sure that it cannot because the kind of calculations and like judgment a designer has to take while working on a project. I mean, it's I'm not sure that even AI can take over that. Not at least for 20, 30 years for sure. Yeah, some automation can be done, but that's different thing. Maybe yeah, like kind of like simulations and everything you want to run that may be assisted by AI. But yeah, creating a test bench is an art. Okay, and it's way more important art because let's say that you have designed a circuit. Okay, and you are not sure whether it's working fine or not because you have basic knowledge of test benches and you just simulated and you said that okay, everything is fine. But real scenarios, okay, real environment is not covered into it. Maybe the silicon will blast. Okay, you'll say that okay, it's not working in silicon. Why? Because you thought it's nice and it was not actually nice. For that, you need to create robust test benches who can actual show you real behavior of circuit so that you can improve it based on requirements. Okay, so test benches are quite important, man. I can tell you that when people with 10 years or 20 years of experience, they don't know how to create robust test benches for obviously for big applications. But yeah, people should focus on that also. Well, after differential amplifier, it's written feedback techniques, but I'll say that before feedback, we'll be again moving to like single stage and differential amplifiers with frequency response. Okay, high speed behavior of transistors, you can say. Once it is done, then I'll be we'll be taking care of op amps. I'll say some noise also will be covering, but only basics of noise because I'm not sure that at basic level noise is required. And if we are moving into noise, it will obviously consume a lot of time. And as I said, that 4 months are not enough because of these topics only. Otherwise, we can easily cover all those things. So yeah, well, after op amps, then we'll move back to stability because once you know how to design an op amp, we'll talk about stability. Okay, and we'll talk about op amp stability. We'll teach you how to make an op amp stable. And second thing is that whatever we'll be teaching you, like after a few sessions, after like beginning few sessions, for like fourth or fifth session onwards, we'll be teaching everything you in theory also or in cadence also. So we'll be showing you, we'll be demonstrate you how all these things, all those gains change actually based on different parameters. Okay, so yeah, that's more into detail. You'll be coming to know later onwards. Yeah, so once after op amp and stability, we can move to actual products. So or maybe like sub blocks you can say, because these sub blocks are used everywhere. So a few of the lists are voltage regulators. Again, it's a very big topic, but yeah, we'll be covering as much as we can. Then we'll be going to band gap references. Okay, then we'll be moving to oscillators. Then we have PLL and data converters. So again, PLL and data converters are a quite big domain. Apart from the basic circuit design, you need to know a lot of other things like communication stuff or other side or like noise stuff, jitter stuff. So yeah, we'll be covering as much as we can based on the timing. But yeah, our idea will be to get you placed also. So we'll prepare you accordingly. Okay. But yeah, like we'll launch you in that field, and maybe you can explore more in future if you want. Well, after like these topics, we have a mini project. So like out of these four topics, one can choose a product and they can do their project work onto it. Okay, and we'll make sure that all things are well covered. Then after a mini project, we have mock interviews and personality development, sessions. Okay, so I'm sure that this is well enough to cover required things which are expected from a fresher in industry in circuit design. Yeah, some basic things like some basic network analysis also we can cover. Well, after not like okay, so in order to cover more and more and learn more and more, I'll expect people who are joining, they should be well aware of basics of electronics. Let's say that you should be knowing about network analysis. You should be knowing about KCL, KVL, some basic circuit theorems. You should be knowing about basics of control system. Even if you don't know, well, we'll teach you, but yeah, we'll not spend much time into it. So it will be better if you know about basics. Okay, and that's the prerequisite for this course. Okay, so yeah, well, as I have already covered most of things, but yeah, maybe like you can have a glimpse on these things. So what we are going to cover in device physics. So as I said that it's MOSFET structure, it's region of operation, it's small signal modeling. Okay, but we'll be covering way more than this for sure. Okay, well, we'll be talking about FinFETs also. We'll be talking about GFETs also. We'll be talking about the challenges in MOS. We will be talking about types of MOS devices available in a particular PDK. Okay, so well, it will be well aligned because I've seen that people who have good circuit analysis, they are generally not aware about device physics or like device structures and everything, and they are actually like scared of layout things. But yeah, you have to take interest into layouts for sure. As a designer, layout must you should not be scared of layout. The more you know about it, the more good decisions you can take. Okay. So, well, then this is about Linux. So in Linux, as I said that you should be knowing how to copy a particular file from one source to destination directory. Okay. Then yeah, I'm sorry. Yeah. Okay. Well, then the CP minus R is nothing but copying entire folder from one place to another. Okay. Then this move command is for moving the files. Okay. Well, the way you do in the copy paste in Windows, same way we have to do in Linux also. It's not difficult. We like in 1 or 2 days you'll be comfortable enough regarding this. Well, this is about Linux and Cadence tool. So as I said that Cadence is kind of customized. So if you see let's say this is a Cadence tool. Okay, I'm sure that this apart from this logo, a lot of things are changing for different people. So let's say that you are purchasing license of Cadence from Cadence, so they can get you customized according to your need also. So yeah, but basics are mostly same. I won't be having any problem into it. So yeah, like we'll be teaching. This is the Cadence Virtuoso, schematic editor. So obviously, we'll be teaching you how to create schematics, symbols, and then like how to create test benches and everything. Well, after that, okay. Also, we have AD, which is nothing but a simulator, spectral simulator. So we'll be, teaching you that part also. I have already covered, I think. Then in single stage amplifier designs, yeah. So just it's a basic glimpse what we are all going to teach you. But yeah, there's much more than what is shown here, and it will be more useful for interviews also and for design purpose also. While teaching these topics, we'll be taking care of interview questions also, how someone can ask you a twisted question and why you should not be afraid and how should you face it. Okay, so these things. Then we have differential amplifier design. So obviously we'll be teaching you first basic differential amplifier, then we'll be introducing current mirrors and embedding that current mirror inside differential amplifier itself. So this circuit is nothing but a current mirror and it's not that much difficult. We'll be taking care of that also. Then these are feedback techniques. So we'll be teaching about stability, why stability is required, what is the need of stability, right? Poles and zeros and everything. So for that purpose also, I'm expecting you guys must be knowing control systems. But if you don't know, we'll be taking a quick recall to basic undergrad courses, and maybe we can jump back to this topic. So yeah, it's quite interesting, by the way, this feedback techniques. Then stability analysis, it's a part of feedback techniques itself. If you are going to teach you feedback circuits, then obviously stability is required. So yeah, we'll be taking care of all these things. Again, while in this process itself, we'll be covering basic circuits also, which are useful in interviews. Then we have op-amp design. So different types of op-amps are possible. We'll be teaching you those kind of. I'll be covering focus. I'll be having focus on that amplifier, which is widely used in like industry. So folded cascode is something people use on day-to-day basis because of its higher gain and everything. But we'll be covering other also in order to reach at folded cascode amplifier. Obviously, you should be knowing differential amplifier also. You should be knowing, like this single stage amplifiers also. Then you should be knowing others amplifier architectures also. Then only we can jump to folded cascode. But yeah, it's quite like prominent, we can say, in today's time. Okay, then like once you know about amplifier and once you know about stability, I'm sure that if we can take care of this regulator part, it has nothing. If your fundamentals are strong, we can cover it in a day or two also. But if that is weak, it will take months also. So make sure that your fundamentals are well established during the process of this course. And I'll encourage every one of you to ask questions during sessions. And also, like if you don't know something, if you're missing something, I'm sure that that will be taken care of. But yeah, people are encouraged to do their homework properly. I'm sure that people who are already working, they have time crunch, but this course demands your own time and attention, right? So if you are going to spend time into it, I'm sure that it will be useful. Okay, then after level regulators, we have band gap references, and they are again kind of you can find it everywhere. This band gaps, any application, any product, you'll find you need a clean supply, and band gap is and regulators are must there. Okay, so they are a good start for someone who is willing to switch into circuit design. If you know about these, I'm sure that you'll be able to crack interviews. Then we have oscillators. Yeah, so oscillators is a different domain. We'll be covering basics of it, and then we can move ahead because it will take years also to spend these things because oscillators are full-blown products in themselves. Okay. Then we have PLLs, again, PLL and when I said oscillator, obviously PLL was included into that because PLL and oscillators are taken together. So if you can see that this is a big general loop of a PLL, and that PLL, this VCO part is nothing but voltage control oscillator. So once you have to learn oscillator, then you have to learn feedback, you have to learn loop stability, you have to learn charge form, then you can understand the PLL thing. But PLL is a big thing. It will take time. I'll make sure that I'll teach you basics of it. Then we have data converters. Yeah, they are used everywhere, obviously. Like your like phone camera you have, okay, obviously. So in order to capture the image, the light enters into your camera sensor, and that light intensity is measured, and okay, and it is measured in analog way, and then that data is converted into digital circuit. So that's why your photos are stored digitally. Okay, so like ADCs are used in a lot of places. Image sensor is just an example. Temperature sensors. Then we have things like high-speed communication also we use, and they are one of the challenging blocks, you can say, data converters. Yeah. So people who have deep interest in circuit design only, they can stay in this domain and they can work for longer. Okay. Once who have interest in system design, okay, they can have a look at it and they can move ahead to being system architects. All have, like both fields are completely different. Okay. Well, after that, this mock interviews. So obviously, well, the basic part is that, okay, after this course also, let's say that you are writing a resume, okay, and you're sending it to someone, and I'm sure that people are in hurry, okay, they have certain requirements and they look for those points only in the resume. So well, will be teaching you how to create a good resume so that it can catch eye of recruiter. I mean, mostly managers, I'll say. Then we'll be having mock interviews, okay, and mock interviews will be quite difficult. It may be way more difficult than what is generally being asked in real interviews because obviously retake interviews, so what you know what to expect. Okay, then we have course completion test. We will see how much you have learned after this course, after the course is completed, right? Then personality development sessions will be held for sure. Will we make sure that you are placed? We'll be there with you at last moment. That's what I can say. Okay, so that's it. Well, that's from my side. Well, I think it's your time now to ask me questions. Any questions, anything you have, please feel free to ask. I'm sure you might be having a lot of questions, a lot of doubts. This is the time. Yeah, I'll be waiting. And let me jump to Zoom. Okay, so I think a lot of people are here. Well, I have covered my part. What about you guys? What do you think? Anyone have any questions regarding any topic? I mean, feel free to ask. There is no problem. Like I'm sure that if you are interested about this course demo session, like no one is judging you because obviously we all have to learn. We all keep learning. So please ask questions. Anyone? Okay, I see 10 people are there.
Hello.
Yeah, Shubham. Yeah, please go ahead.
Actually, Abhijit sir, actually, see, I am a working professional. So
Okay,
currently, already means I am working in HCL. Okay,
okay,
and but as a design engineer. Okay,
okay.
so my profile is like a hardware design engineer. Means we are
Board design, right?
working. Yeah, yeah. Board design means
Okay,
we are working on application level.
definitely,
So,
yeah.
yeah, there are
Yes,
miss ECU project, BMS project,
yes,
such kind of projects. Okay,
yeah.
designing. So,
Okay,
but now see, miss, I want to learn the analog design. So
okay.
that will align with my those experience, or this is completely
Oh,
different. So such kind of confusion
let
is
me tell you.
there.
Let me tell you, buddy. So you have a board, right? Okay.
Yeah, yeah, correct. Yeah,
Yeah. I'm sure that you must be having some chips on the board.
yeah,
Correct?
obviously, yeah, yeah.
Yeah, correct. My question is that what you have learned, how much experience you got?
Now 4 years.
4 years. Okay, fine. Now
Hmm.
just tell me one thing. Let's say that you forget. I'm asking you to forget this field right now and move to circuit design. Obviously,
Hmm.
circuit design is more complex because inside that black chip, the circuit will be 100 times bigger than what you are seeing on board. Because on board you can see circuit with your open eyes. In chip you cannot see. And
Correct,
that's
correct.
about that's about assumption, but I'm telling you circuits are quite big. A lot of modules are there. I'm sure that on that particular chip at least 50 or 100 people might have worked on, from digital side to analog side to layout side. Okay, so
Yeah,
the
yeah.
thing is, the gist is like right now you might not be aware of basics and something, and the problem within the industry is that okay, if someone can do something, they simply recruit it and hire it. Okay, no one bothers about your career. Okay, where you want to go and what you want to do in life, right? The thing is
Yeah,
that once, let's say, you jump into analog circuit design, you take up small blocks. Let's say that if someone has given you a task to design band gap, then they'll start trusting you. Then you'll be given bigger blocks. Then you'll be having ownership of like a big subsystem itself. Then someday you'll be a chip owner also. And even if you're not, let's say that you are owner of a complete top level, right?
yeah,
Now
okay.
that chip, once you have designed it, what you will do with it? You need to test it. You need to see its application. You need to integrate it into a big system, and that big system is nothing but a board.
Correct. Yeah, yeah.
I'm sure that those circuit designers, those product owners, they know well about your boards for sure. So since you know it, it will be plus point for you because you won't have to learn it in future. Well, I'm telling you my story. Yeah, like once chips are done, like we have to do post silicon debug and everything. Okay, so for that we have to go to lab. We have to learn how to use this oscilloscopes. We do need to do TDR things. We need to do S parameter things. Okay,
Yeah,
all
yeah.
those things are there. So you cannot run. See, if you want to be a product owner in future, you have to deal with these things. So you have the plus point. You already know these things. Maybe just keep it for some time. Let's say after 6 years, 7 years, you're coming across that thing again. Kudos. Yeah,
But yeah, but this is the miss added advantage, right? No, miss it is not like
it's
that
not added
the
in one. Yeah, like what you are doing right now, it's not a waste. That's what I'm trying to say.
yeah, yeah.
But yeah, like if you are going to be a board designer only, it's completely your choice. But I'm well aware that I'm sure that if you want to keep your career into board design only, I think you should move from board to this software stuff also. And software is kind of boring to be sure. Like for me, it's boring. Okay, I'm a kind
Mm-hmm.
of a mathematics guy who like to write small signal models, who likes to do integration at this time also. Okay, so if you want to do these kind of, if you love this stuff, okay, I think you should be continuing to ACD. Okay, and this thing will be your added advantage. So why I'm trying to tell you that, like at the start of my career, also long back, okay, I was interested into embedded systems. Okay, so it was
Mm-hmm.
quite fun to use a solder and a breadboard. Okay, and a perforated board and just join resistance, capacitances. Okay, and ICs together and see how it's working oscilloscope, right?
Yeah,
But
yeah, yeah.
soon we'll realize that okay, things are not working, man. There's a lot of noise. Oscilloscope signal is very poor. How to improve that? Then I started
Mm-hmm.
searching. I found that okay, like a lot of ICs are there in market. Then I said,
Okay.
okay, fine. What can I do in boards? Then I found out that okay, after on you just have to know about your board design. Then you have to know about different ICs and their data sheets, their parameters. Then you have to know about software also. Like at some point of time, most of your time will be spent on like firmware and other things because those things are quite integrated, right? So
Correct.
I mean, like if you want to stuck as a board designer, I'm sure that some small equipments you can definitely design, like a pulse oximeter and other things. Okay, where not much of software is needed, right? But
Mm-hmm.
all those lucrative zones, let's say that you are going to design a smart TV, the board of an entire smart TV. You
Yeah,
need to
yeah.
know about software, and software engineers are more preferred there. So that's
Correct,
the
correct.
reason also, like I choose this field as my career, and I'm well happy. So once let's
Mm-hmm.
say that because those chips are ocean in themselves, right? A lot of things are there. I mean, if while designing based on applications, you need to know communication system, you need to know like signal systems. And people normally think that okay, analog circuit design is nothing but like MOSFETs and everything. But no, man, you need to know entire electronics. Let's say you're working for memory, so you should be knowing about memory structures, address bits, like micro controller architectures and all. If you are working for communications, right? Let's say that you are designing some serial link chip. So you must be knowing
Mm-hmm.
about signaling schemes. You must be knowing about Nyquist theorem, other things like FDM and all.
Mm-hmm.
Communications concepts are must required for that domain. Let's say that you are working for some biomedical application where you have to design chips for like human and machine interface. There you need to know about basic signal systems, human like biological systems and everything. So
Yeah.
until and unless you don't know those things, I'm not sure that you'll be able to succeed much in life. So right now, these are fundamentals. Let's learn this. Let's work for like 4 5 years. Okay,
Yeah, yeah.
then when you'll be expert, then you'll be taking care of like system level things. And at that time, these basic things will be like on your fingertips for sure. That's what
But
I can say.
see, there is another side like pay
Yeah,
scale, right? For
yeah,
example, see, I'm focusing on 1 or 2 years. I'm focusing on the analog design, okay.
yeah.
But till now, already I have some decent package, okay. So
Okay.
whether and now I means I will plan to switch into the
Yeah.
analog circuit profile, okay, in
Yes. Yes.
another
Yes. Yes. Yes.
organization.
Yes.
So
Yeah.
my current package
Yeah.
will match in that particular company, or will I ask more? You are understanding, right? What I'm
Yeah,
at.
I'm well understanding your fact, but what I'm trying to say that don't move for short-term goals. Okay, I mean like I'm sure that if you are experienced enough, if you have a decent package, okay, they'll make sure that you are not dissatisfied enough. But if you are thinking that, let's say that you will be, let's say that someone who is an analog designer of 4 and 5 years experience, right? He's getting some
Mm-hmm.
salary, right, and he'll be getting hike over that salary itself. You
Yeah,
can
yeah.
expect the same amount of hike as he is getting because for that point of time he will be more useful, but
Correct,
in the
correct.
long run you will be more useful. So obviously in the end your worth is, look, see, no one takes your worth, right? It's just delay,
Mm-hmm.
1 or 2 years, 3 year delay, but yeah, you will get your fair share, no? All I can say. So let's say
Correct.
that someone who has worked in this domain for 5 years and you are working in board design, so you have worked a lot. Let's say that
Mm-hmm.
in upcoming 5 years you have achieved a lot of things, you've learned a lot of things. And
Mm-hmm.
someone who is working for 10 years, he's obviously he has 10 years of that core experience, and in that 5 years I'm assuming that you have done more work than him. So you'll be having 70% of or like 30% less experience than that person, but you have a like plus point, which is your system level design. And once you are into this product domain, man, like those people are mostly managers or like principal engineers, and at that time, like we don't talk about few lakhs or something. Okay,
Yeah, yeah. Yeah.
so yeah, so that's the thing. So don't have to worry about if you are interested into circuit design. Yeah, I'll say it's some I'll say you should opt for it after this course, or maybe like you should study yourself properly apart
Mm-hmm.
from sitting here. But let's say that out of some motivation you join this course, okay, and you're not studying yourself on regular basis. I mean
Correct, correct.
then you might be not getting the amount of growth which I'm promising you right now.
Correct,
And
correct.
okay, yeah, I'm telling you,
Yeah,
things
yeah.
are there. Okay, so one good thing about industry is that let's say you have you don't want to work. No, let's say that you don't
Mm-hmm.
want to learn much. Okay, no one will bother. They will just keep you in that category only, and they'll give you work which you can do easily, and your growth and everything will not be that much because people are there. People have different preferences, right? Some
Correct,
have
correct.
family preferences, some have like career, some have other things.
Mm.
Okay, so yeah, it's totally up to you. All I'm trying to say that there's a big gap between industry and academics right now in India. Okay,
Correct,
we are
correct.
doing nothing. We're just trying to bridge that. Okay, a bit
Mm-hmm. Yeah, yeah.
because what all you can get is that like some research papers, some other things. I mean, like what's the point of reading a research paper when your fundamentals are weak? And I'm sure that there is no one who can teach you for the fundamentals, right? Either you have to do it yourself, or maybe you need someone who can accelerate that learning. Okay, we are just trying to do that only. Okay, so in a way, I'll say that people. I'm not sure what people think, but yeah, people should be thankful for these kind of courses because they actually launch you into industry, which is kind of difficult. If you see that years back when these courses were not there, like people used to do what? Like people from IITs or NITs used to get hired into VLSI Tech. But now India is growing, a lot of opportunities are there. So like these courses are actually enabling people to like jump into industry. And yeah, some people might have done this course in like 5 years back also, 6 years back also, and they are working as a lead. Okay, so that's not
Correct.
a problem. All you
Hmm.
need to have is a patience. Okay,
Yeah, yeah.
yeah,
Yeah. Thank
learn
you.
and yeah, that's all.
Yeah.
Okay, so I think someone like wrote something in chat also. Who is this? Subramanya. Okay, what did you say? Yeah, let me read. Okay, so you're saying okay, okay, you are asking something or you're just like supporting my point. Okay, that's great. Yeah. So like to I mean like to have your career into analog design, I'll say that electronics is a must thing. Maybe you can choose your domain. Right now, you must be thinking about like salaries and circuits and only. But after all, these circuits are normally used in some products only. Okay, what is the product? Based on that, your skill set will be needed. So let's say that you are working into some serial link or communication product. So people expect that you know what is basic communication theory and all. If you're working in some SOC, obviously you must be knowing about microcontroller architecture, microprocessor architecture. If you're working in, as I said, let's say some sensor kind of thing, then pure instrumentation kind of stuff, then obviously instrumentation knowledge is required, right? That's what I can say about me. Yeah. Okay. So anything else have any, sorry, anyone else have any question? Maybe as you can ask more and more if you want. As don't hesitate, please ask. We have 10 more minutes. We can you can ask questions if you have any doubt, if you have any concerns, feel free to ask. I'll try my best to answer the question. Okay. No one has any like interest in like that thing called you know the content, of course. I mean like okay, Shubham. So like, I'm asking you that thing. So do you know something about circuit design? A basics idea? You have some basic idea?
Yeah, yeah.
Basic
See,
idea. Let's say. Yeah.
circuit design in the sense, see, means I know about the like fundamentals of means devices like MOSFET and the
Yes. Yes.
yeah,
Yes.
I mean
So
physics
I'm
level.
sure that you must be knowing about MOSFET behavior, its characteristics, and everything,
Yeah, yeah,
so that you can
everything.
mostly from discrete point of view, right? Discrete components, right? But yeah, chip
Yeah,
design is
yeah, yeah. You can say that,
something.
but
Yeah.
in the sense of physical level as well, I have some ideas like, and even I
Okay.
have some ideas like small signal and the large signal modeling as well. By
Okay.
because yeah, it's a self-study kind of thing.
Yeah, that's great. Yeah.
Uh,
Okay.
so
Well, one thing I'd like to add apart
apart
from yeah,
from
yeah.
this, for the circuit designing means I have MSc. We have experience in like Cadence, Cadence or software. Like so, in that we are
Which
just
one?
designing the
Alargo?
electronic circuit in discrete level.
Yeah. So Cadence Alargo you're talking about?
Yeah,
Allegro
yeah,
or
Allegro.
Alargo
Yeah,
something?
yeah,
Yeah.
correct,
Okay.
correct.
Okay.
Yeah.
Okay. Yeah. So that's for PCB design mostly. Yeah. So PCB has its own field, man. I mean, like they have its own challenges. Yeah. So we cannot talk about it. But yeah, circuit design, it's totally different field. So why I'm talking about circuit design because when you read about MOSFET and circuit design, it's not
Mm-hmm.
just a MOSFET and its basic operations. We talk about challenges in MOSFET which normally come when we try to implement it into like that chip level, right? So
Mm-hmm.
in discrete component, let's say that your MOSFET has four terminals and like four terminals, and you can yeah you have a like freedom to connect any terminal to anywhere, but we don't have that much liberty in like actual chip because we have to think about floor plan also, area also, and process itself. So sometimes process does not allow us certain things. Okay, plus there are multiple effects which needs to be taken care of while designing a circuit in an IC rather than a discrete circuit. So you might have read about circuits like differential amplifiers. You can easily design it. Okay,
Yeah, yeah.
like using discrete components. Like okay, and let's say that you are using some old op-amp 741 IC. I mean those things are already done. But in lower
Mm-hmm.
nodes, when size is quite smaller, we have multiple more challenges, and I'm going to talk about it for sure.
Correct,
So
correct.
we have challenges, okay, and we have phase problems. We have different kind of problems. We have reliability issues. We have PVT issues. Let's say that you have designed some MOSFET, okay, and you're thinking that it will be working fine, but during fabrication, what happens that MOSFET becomes slow, okay.
Mm-hmm.
So obviously, whatever we intended to do, it will not be completed. So PVT is way more important thing. Then we have some other issues like let's say that during fabrication something happened, some earthquake came, or maybe someone walks because of vibrations. Your chip is not the way. We do
Correct,
Monte
correct.
Carlo analysis. It's a
Mm-hmm.
There's a lot of risk involved into it. Okay, so one
Mm-hmm.
test chip means let's say that it's millions are spent in designing cost itself, and then we have fabrication cost. And if chip fails, and that's problematic. So risks are more. So learning is more. Like knowledge required is quite more in that domain. That's what I can say.
Correct.
Okay, so I
So,
think someone has written. Yeah, please. Yeah, go ahead.
see, means here we are means dealing with only Cadence Vertiso or the Synapses as well.
Well, I have worked on both. Actually, I'm more fond of Synopsys because I have worked with Synopsys tools on for a longer time. Both are
Uh-huh.
same only. It does not matter. Okay, I can tell
Both
you
are
that there are companies where both tools are opened from some people use Synopsys, some people use Cadence. So it's all about database. As I said that once you know about Linux, you can launch that those files using any of the like tool. So only difference is a bit of like some bind keys and some positions. Let's say that you want to draw a wire, so you have to press W here and one there. Okay, maybe and the some icons are kept at different places. That's it. It's not a problem.
okay, okay, got it. Yeah.
Okay, yeah. Just a moment. Yeah. Okay. So DSP and DSP is important. We'll say. Okay. So yeah, DSP is. I'm not sure. Well, if you are going to work as a product level designer in future, you might use it, but for the beginning, I'm not sure you'll be needing DSP. Again, learning, there's an entire C to learn. Right now, you're talking about analog circuit. 10 years later, you might be talking about entire SOC. Okay. So obviously, for that purpose, DSP is needed. But for the beginning, it's not. Just beginning, and whatever I'm teaching you, I'm sure that you can get into industry. And once you are done, it's your choice which field you want to opt, how much you want to grow. You have to do it. But DSP is because digital signal processing will be doing on what? Some chip must be there, right? So a designer needs to know these things. Okay, so one more person is there who is saying you have been working as a faculty for last 10 years. Okay. Yes, sir. Yeah, that's true. I mean, like, I understand that you're 40 years old, but again, it's your call. What do you want to do? But if you want to pursue, there is never late. I'm not sure if your salary expectations will be met in industry right now at this point of time. In case you're joining some product-based company, then definitely they'll meet you. But in service-based company, like it's all about revenue. So in service-based companies, what happens that let's say you're going to join, right? And you are billable, so they might give you more money also. That's not a problem. But as a fresher, let's say that you're not useful to them. After our training, also, let's say you join industry and they will think of training. So they will see how much you know. Based on that, your growth can go. But I have seen people in past who joined at late age also as a fresher in circuit design. It's all about their passion. So, I mean, I don't know. I'll recommend if you're really interested into circuit design, I'll recommend. Let's say that you're working as a faculty and you're not getting that much growth. Right now, industry also you'll not be getting that much growth for 1 or 2 years, but in 3 years' time, I'm sure that your salary will be well enough, you know, so that you won't you won't be bothered. I mean, at some point of time, let's say that you are getting enough money in then you don't bother about some few lakhs or something. That's what I can tell you. So normally, what happens that initially there's a struggle. Okay, let's say that right now I'm getting 5 lakhs. Let's make it 10 or 15, 20. People generally don't understand that once your salary has crossed the limit, let's say you are 30, your salary is 30 plus now. So the amount of responsibility which is going to like come on you will be quite vast. So at that time you will be thinking, okay, yeah, I should be having some personal time. I'm not getting enough time for my family or something. So priorities change. I've seen. So yeah, I mean, like if you are planning to be a manager or something, obviously in future you have to wait for 10 years, I'm sure, because that's how the path looks like. But yeah, in few years you can be getting enough money so that you won't be bothering about money for sure. Okay. I mean, there are people who have experience of 15 years also, they are getting 30 lakh because they are not interested to grow more. They just want to live their life peacefully. So the kind of work which is given to you will be less risky. But some people who have, like more intention to take risks, more intention to work hard. So hard work is rewarded everywhere. Okay. Obviously, like you see that out of thousands of people, only one is CEO because he has taken, like he has grown and he has proved himself at different stages. Okay, so I'm not sure I can comment that. We all try. We all have some, like destiny will reach. Okay, so that's your answer for your question. Anyone else have any question? If you have any more doubts, please feel free to ask me. Okay, and maybe you can have a personal call with me also. Needed. Okay, you can contact Chetra. She will guide you for that. Okay, anyone else have any questions? Yeah, we have a few more minutes. I'll appreciate. The more curiosity, the much better. Maybe like if you're asking something and I'm answering you, that answer might be useful for someone else also. So don't hesitate. Feel free to ask more questions. Mm, okay. I think how many people are there? A lot of a lot of people are there. Please. Okay. 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 So I'll be waiting for 2 more minutes. If no one has any questions, or maybe like we can end this call. That's it. Okay. I think
Yeah,
Shubham
hi
here, right?
Abhijit.
Yeah. Yeah. Okay. Yeah.
Sai Kiran here.
Yeah.
So yeah, you said like op-amp designs as well as LDOs and BZRs, right? So I'm a
Yeah.
layout engineer.
Yeah.
So I wanted to know like I know the basic stuff
Hmm.
like this
Okay.
circuit is the input and we draw the layouts and we give that. So
Okay.
designers will come and say like this spec is not meeting and that is not meeting something like
Just a
this,
moment,
right?
second. Can you raise your voice a bit? I think your voice is
Am I
quite low.
audible now?
Yes, you're audible, but your
Hello.
voice is quite kind of low. So yeah, please go ahead. Yeah. Hmm.
Yeah.
Okay. Yeah. So I understand that spec is not meeting. Yeah, and all. Okay. Fine. Yeah.
Yeah. Oh, so yeah, like you will be teaching all those stuff or like what is happening.
Okay. So yeah. So the thing is that designers, let's say that if you are dealing with some junior designer, because mostly you'll be dealing them because they are one who asked you to get block level layout. So they have been given some specs, right? And they want to meet. Obviously, they want to meet those specs, and for that there's a lot of difference between pre-layout and post-layout simulations. Okay, it's there. So some basic techniques are used for improvement so that we can get better results. Obviously, while talking about, as I said, that I'm going to cover in extensive manner, right? So those things will be taken care of. That's what I said to I think Shubham also when I said that it's not a discrete MOS, right? You just don't have to use general equations and get the results. I mean, MOS as a system, MOS as a in like if you talk about MOS and like PDK thing, a lot of problems are there. We assume that our gain will be let's say 20 dB and we are getting 15 dB also. So we scratch our head. Okay, why it's coming as 50 dB, 15 dB? We how can we increase it? What is bothering us? Whether it's capacitance, resistance. So you have to think. Once you think, then you will talk to layout designer. Okay, that I'm getting this problem and how to solve that. So layout designer must be using telling you something based on his experience, right? But let's say that you have idea about circuit design at that point of time. I'm sure that you'll not make those mistakes in layout which you make as a beginner. Okay. So my question is let's say that you have some op-amp. Okay, our designer is saying that it's quite critical. So there are multiple op-amps inside a particular product, right? Some have very critical requirements because they are a part of main signal path, and some are just for testing purpose, so they don't have that much of critical requirement. Okay, that's why people are adamant sometimes. Let's say that you are doing okay, which domain you work in? Like if you are working as a layout designer, how much experience you got, and what's on what product you work on? Can you give me a basic idea?
It's an Sardis I do actually.
Cerdis, right? Yeah. So from Cerdis, let's
Yeah.
say that we are talking about this high-speed clocking. Okay, you know that
Mm.
from PLL a clock is coming, right? Clock is coming. It's traveling a long distance, like 500 micro, 600 micro. Okay, and designers always say that okay, please try to shield these clocks from outside world. Do a differential shielding also. Try to reduce the sheet resistance. Okay, and try to reduce the cap also. Please add a no fill. These things you might have heard, right?
Yeah.
Yeah. So they say that it because like let's say some resistance is there in routing itself, it will be an RC circuit and it will degrade the performance like duty cycle and everything. Okay. So it's SerDes. SerDes is mostly about digital signals and clocking and stuff, inverters. We'll be talking a bit about it, but we'll be talking these things in op-amp scenario. That's what I can say. Not only this, let's say that someone say that okay, please try to do more stacking. Let's stack metals over each other. Let's say you're going to design a custom inverter, right? In that case, they will say that okay, you are using only three metals. Try to give more via. Okay, please use bigger via. Okay, these things generally designers say to you, right? I'll give you answer to all those questions. Why these things are said? Why they say if you might have seen that okay sometimes the wires the schematic buses which are designed they are done in some purple color to highlight that this is high speed path. Okay, so you have to take care of its layout. Okay, they also mention that matching is quite required. So let's say some amplifier is there where matching where we are quite specific about its property. Okay, its specification. We don't want it to change across PVT because it's used in some critical path where we cannot afford to have any error, right? So that's why I say that okay, critical design, please match these kind of things. You know, then EM stuff is
Okay.
always there. We'll talk about that also. We'll talk about aging, reliability, everything. So I'm not going to teach anyone based on that the textbook stuff. Okay, I'm sure that you can find it anywhere, everywhere, right? And a lot of notes are there. What I'm going to tell you will be a lot of practical experiences which I have seen. Okay, when I'm going to teach you about design, not with single stage amplifiers. Let's say I'm talking about a block. Let's say band gap. So I'll be taking care of layout part. What is critical? Why we have to do these kind of things? Why offset is important? Whether offset is important in that band gap or not, and if it's important, why it's important. All those things I'll be telling you. So designer ask you to get accuracy only when it's needed for them. Okay, so we have to understand why it's needed for them. Once you do it, it's okay. And since you already know about layout, man, it's quite like uh, go for you, I'll say. I mean, because a lot of people have say that like I have friends who are layout designers, okay, and they are into their comfort zone. Since you are coming out of it, I appreciate that. Okay, okay, that's what I can say. Any other question you have?
Thank you.
Yeah.
No, that's it. Thanks.
Okay. Anyone else? Please, they have any question? If they have any question, please feel free to ask. Maybe it's 7:34. I'll be waiting for one more minute. Then maybe I'll just close this call. Okay. Okay. So I hope that I was able to provide relevant information from this call to all of you. Well, hope to see you again. Okay, I'm stopping the recording.